Alright, this is the fourth and final part of the test. Some review questions that are still quadratic functions. Let's start here with number 14. Alright, let us factor completely. What is the first step of factoring, my friends? GCF, greatest common factor. I'm reminding you of that because at a glance it jumps out at me that all three of these are divisible by 2. So you really want to pull that out first. Okay, so if I do that, then I pull out the 2 and hold on, let me do it like this. When there's a GCF, you pull it out and you make one set of parentheses, just one at first. And then you try to see what's left behind. Okay, to know what's left behind, you divide everything by your GCF. Okay, so these 2's would cancel, so that's x squared. These 2's would cancel, so that's plus x. 4 divided by 2 is 2, so that's minus 2. Alright, so far we've got this right here. Okay, so it's possible that C is the answer. But we're supposed to factor completely, so we need to check and see if we can factor the pink part. If we can, then we must. Alright, but already we know that the answer is not A, alright, because we've pulled out a 2, so that means it's not prime. We know the answer is not B, because B doesn't have this blue 2, which should definitely be there. So it's either going to be C or D. Okay, so let's check this out. X squared would factor as x times x. 2 can only factor as 2 times 1. Now we know that inner plus outer must equal the middle. Inner we have 2x. Outer we have 1x. This must equal the middle of positive 1x. Is there any way that we can get 1x out of 2x and 1x if we pick the signs right? Yeah, if we have a positive 2 and a negative 1, that will make 1x. So positive 2, there you go. Negative 1, there you go. Will that give us negative 2? Sure, negative 2 times, positive 2 times negative 1 is negative 2. So this is correct as far as factoring the pink part. But let us not forget the 2 GCF that we've pulled out. So we have 2 times x plus 2 times x minus 1. And there's 2, and there's x plus 2, and there's x minus 1. So this right here is a match. So that's why the answer is D. It is in fact D. Okay, if you picked C, well, you weren't wrong except for the completely part. Alright, D is factored completely, C is not. Alright, number 15. In my class, I had students just choking on this. Like, what? We never learned how to do this. I don't know what to do. It's not fair. It's not fair. Well, you know, first of all, stop crying. It's just one question. Second of all, you do know how to do this. Look, if you have n to the third power times n to the fourth power, okay, can you tell me what this is? Okay, hopefully you said the right answer, but let me give you some choices. Is this going to be n to the 7th power, or is it going to be n to the 12th power? Which is it? Yeah, it's n to the 7th power. Okay, you don't multiply the 3 times 4. And you knew this because n to the 3rd power means n times n times n. And n to the 4th power means n times n times n times n. Put it all together and you have n to the 7th power, so it makes sense. So that's the same thing here, just with numbers that are too big for me to be writing that many i's. But once you remember that when you're multiplying variables, like variables, you add the exponents. Once you remember that, then it becomes very clear adding these exponents, right? 23 plus 45. Okay, so we have I to the 68th power. Alright, I'm adding 23 plus 45. So then it's just a matter of simplifying I to a power. Now here's what we learned about that. We learned how to make the chart out of it. Okay, and the chart was like this. We made the chart, man. Okay, so it started off with this, my good friends. We said, look, what's I to the 1 power, and what's I to the 2nd power, and what is I to the 3rd power, and what is I to the 4th power. That's how we started it out. And then we said to ourselves, we know the answers to these questions, not fooling anybody. I to the 1 power, that's just I. No big deal. I squared, we memorized this a long time ago. I squared is -1. We're halfway there. If I squared is -1, then clearly I to the 4th power is +1. How do I know it so well? Well, because I to the 4th power is the same thing as I squared times I squared. Alright, so that's the same thing as -1 times -1, which is +1. So there you go. I to the 4th power is +1. Okay, or just memorize it. I to the 3rd power is the one we learned last, but that is -I. Okay, if you wanted to figure it out, like say if you weren't sure, you forgot, here's how you would figure it out. You would say, okay, well, I to the 3rd power is the same thing as I squared times I. That would be I to the 3rd power. But I squared is -1, so this would be like -1 times I, which would just be -I. So there you go. I to the 3rd power is -I. After that, in this 3rd column, we think about money for the decimals. Think about quarters. 1 quarter is 25 cents. 2 quarters is 50 cents, but you could look at it as 0.5. 3 quarters is 75 cents. And 4 quarters is 1 whole dollar, but it's important to focus in on the fact that we've got no decimals here. No decimals. Okay, so if you want to solve one of these problems like I to the 68th power, here's what you do. You take your 68 and you divide by 4. Okay, yeah. 68 divided by 4. Well, that's 17. No decimals. Okay, so because it has no decimals, alright, that means that I to the 68th power must equal 1. Okay, so that's why the answer is D. Alright, if it had equaled something with a decimal of 0.75, I would have picked this, or 0.5, I would have picked that. 0.25 on the end, I would have picked that. But no decimals, it's a 1. Okay, what else you got? What is the range of the function blah blah blah? Well, this is a parabola. Okay, this is a parabola, but if I want to talk about the range, I need to know what the vertex is. So I would start there. Let's start with the vertex. Alright, vertex helps me know the range. If I want to find the vertex of a parabola, in standard form, then the x value of the vertex is going to be opposite of b over 2a. So in this case, I know that a is 1, b is 2, and c is -3. So opposite of b over 2a, that's -2 over 2, 2 times 1. Okay, so that's x equals -1. So fine, -1 is the x-coordinate of this vertex. Okay, now if I want the y value that goes with it, I basically need to plug in -1 for these x's. But I'm going to use my TI-30XS multiview table function to do that for me. Let's see, x squared plus 2x minus 3. Okay, so x squared plus 2x minus 3. Now I want to know what's going on at -1, so I will start at -1. -1 comma -4, that's my vertex. Okay, now that I know that's the vertex, I can do a nice little sketch of my graph. Okay, so here comes a little sketch. Okay, let's say this is my y-axis and this is my x-axis. Alright, x, y. Then the point -1 comma -4, my vertex, is going to be over here. -1, yeah, maybe I should put the marks on there. -1, 1, 2, 3, 4. So -1 comma -4. Now this has a positive leading coefficient, so I know this will be some type of an upward facing parabola. Okay, so we'll be doing this type of thing. Alright, the details aren't important because all we need is the range. Okay, but what I know is this is -4 right here. Now the range is the y values of a function. Okay, so it's how low does it go and how high does it go? Well, this parabola clearly starts off at the level of the vertex, which is at -4, and then it goes up from there. So -4 to infinity. So I'm looking for a range of -4 to infinity. Alright, notice the square bracket on the -4, it touches it. Okay, and there you have it, -4 to infinity. So the answer is C. Okay, that was number 16. Okay, where is the vertex for the quadratic function kabam? Well, this is in vertex form, which is awesome because in vertex form, the vertex is just going to come from this number and this number, but it's going to be the opposite of this comma this. So the vertex will be -1 comma -3. Alright, the inside one is opposite, the outer one does not change. -1, -3. And there it is right there, -1, -3. So the answer is D to number 17. Looks like I've run out of material for my little show. Let me just zoom out a bit just to be sure. Everything is awesome. My daughter has watched the Lego movie like 20 times. Okay, in fact, the first time she snuck downstairs and just ordered it on Comcast. Just bought it, stole it. Alright, so I did hit everything. But as a consequence, I took that out of her allowance. You know I did. But now we have watched that video literally 6 times. 6 times, man. Okay, everything is awesome. We're done, people. That was the fourth and final video. I hope it was helpful to you. Hope it was as fun for you as it was for me. It's after 2 a.m. on a Saturday. Well, technically Sunday morning. Alright, peeps. Peace out. See you on the next video.